One thing we know, due to the availability of data, is how quickly some of those clinical variables change. So, for instance, your HbA1c is a really good example because it behaves a little bit like methylation biomarkers behave, which is sort of a 3-month running average. Sometimes DNA methylation is not the best point in time measure. If you're looking for change, I think as you mentioned, over a day-to-day period, DNA methylation might not be the best biomarker, but over time, we can really see some of those changes. So traditionally, we only recommend testing every 6 months, but we've seen even some of these epigenetic biomarkers change effectively in as little as 8 weeks. I like to use an example of a study that we have done with Stanford and should be publishing soon on vegan versus omnivore diets. We actually took 24 twins pairs, and then we took one twin on an omnivore diet for 8 weeks. We took one on a vegan diet for 8 weeks. And so we really wanted to experiment with this data set to see which of our epigenetic biomarkers might change in that data set, and then help inform us about some of the biological changes which are actually happening there. And what we did is we found 3 things which came out significant, and all of those 3 metabolites have been heavily described in previous literature about changes that happen with vegan or vegetarian diets versus non-vegan or vegetarian diets. So we found things like your platelet factor 4 having decreases, and we know that that's been described in the literature before. We saw that your pancreatic ribonucleases also went down. That's again described with these vegan and vegetarian diets. And so even within 8 weeks, we can see changes of these biomarkers in a really, really clear way. The problem is we definitely need more validation, because some of the things that are included into our algorithm are things that are not regularly measured. Things like Ributol, which only has 2 publications about it ever as a metabolite in PubMed. And so there are some of these things which are really unique and novel, and we really need to find out a lot more about their mechanism. But others, like all those clinical values, which are so well established, we can really see their change in short amounts of time, and we have the data to back that up. So I think it all depends, but we do recommend not being too reactive for some of these and testing too frequently, because we're still not sure about some of the noise on those independent measures. But in the case of your biological age, that is very, very sensitive. We have less than a 0.5% variation if we test the exact same sample multiple times. That is an extremely high level of precision. And that means that if we're seeing change, it's most likely biological change instead of noise within the measurement.
Okay, Ryan. So to summarize that, we're still looking at 6 months as the approximate timeline for self-experimentation. That could change because there's a lot here that's new and unknown. But to just come back to that example, if somebody wanted to make a dietary shift or, pardon me, if somebody wanted to make a dietary change or supplementation change and then measure before and after, we're going to still go with a guidance of approximately 6 months at this time for measuring before and after. Would you agree with that summarization?
Yeah, I think on an N of 1 basis, that's certainly what I would recommend. And the rationale for that, again, is that we never want to give the wrong information, right? In short periods of time, you might have some transient changes that don't reflect the true biological aging changes.